Okay. Today we're going to discuss functions, and we're going to begin a little unit of functions. The next several assignments will be involved in something called functions. So what is a function? A function is a rule which assigns to each x value. Now the next phrase, you could say one and only one, or maybe I'm going to say exactly one y value. It doesn't assign an x value, 2 or 3 y values, only one y value for each x value. We have a special name for the x values. We'll call those domain. Those are the x values. And we'll call the y values range. We're assigning to each x value only one y value. On the first problem, this is one of those assignments I'm just going to go straight through. Oh, wow. Let me write that down. Notice how it says domain range, so it's telling you what the x values are. With these arrows, the number 1 is being assigned the y value of 6. The number 7, what y value is it being assigned? 10. And the number 15, that's an x value. It's being assigned what y value? 6. And the question is, determine whether the, they say correspondence is a function. They're using the word correspondence the way I would use rule. So in place of the word rule, if you wanted to write correspondence, or I think another word they'll use is relation. A function is a relation. I like the word rule, maybe just because it's a short word. But you'll see relation and correspondence used in place of the word rule. So, is each one of these x values being paired with only one y value? Like this number 1, how many y values is it being paired with? Just one, the 6. The number 7 is being paired with just one y value, the 10. Now, sometimes the fact that this one's going back to 6, it gives trouble, but no. The number 15 is assigned only one y value. I claim, yes, this is a function, because each x value has only one y value. The natural question to ask would be, what would it look like if it wasn't a function? What would it need to be? What would I need to do to make it not be a function? Well, if one of these x values had 2 arrows coming from it, like this green, I'm about to make a green mark, which isn't part of the problem, but if there'd been an arrow like this, the number 15 is being assigned both 6 and 10, then that's not a function. Okay, but that wasn't part of the problem. So if there were 2 arrows coming out of one of these numbers, one of the x values, then you would say not a function. Is that clear? Mm-hmm.
So one range can be attached to multiple domains?
Yes. Mm-hmm. In fact, if we just had only 6 and each one of them was paired with just 6, that'd be a function. Okay? But this part right here that I just drew was not part of the problem. But that's what it would take in order for it to not be a function. If there were two arrows coming out of one of the x values. So this is just a yes, no, I think it is, or let me see. Oh, is it a function? Yes. Since we're talking about x and y, you normally think of ordered pairs, x and y. So let's look at this problem, number 2. It says, determine the domain and range, okay, and then tell whether the relation is a function. So let me write it down. So this is one of the problems you can almost just start typing in without actually writing anything down. 45.7 9.6 59.6. Let me check and make sure I wrote it down correctly. 9.7 28 negative 8 45.7 9.6 59.6. Okay. It asks, find the domain. Oh, let me see. Let's look at those instructions once again. Use a comma to separate your answers as needed. Type each answer only once. That's important. So if there's more than one x value, if the x values are repeated, don't write it down twice. Write it only once. So I'm going to write down the x values, but I'm not going to repeat any of them. So the x value, there's a 9. What's the next x value? 28. Then 45. 9 has already been listed, so don't repeat it. And 59. That's correct. Just to save a little bit of the going back and forth, let me go ahead and write the range right now. It's going to say write out the y values, and it's going to say don't repeat them. Okay, write each answer only once. So what will I write for the y values? There's a 7, negative 8. 7's already been listed, so don't list it again. 6 and 6 again. So let me type in these numbers. If you list the same number twice, it'll count it wrong and tell you don't list the numbers more than once. So we go 9, 28, 45, but I'm about to do this wrong. 9, 59. If I list that 9 twice, look at what it tells you. Be sure that you have listed each value only once. So I need to come over here, click, and remove the 9. Now, for the y values, there's only 3 of them. 7, negative 8, 6. And now it says, is this a function? Well, I sort of like these arrows like this, because with the arrows, if there's 2 arrows from one x value, then it's not a function. So I'm going to draw the arrows. Like here, the 9, 7. I'm just going to draw arrows. Then the 28, negative 8 goes like that. 45, 7. Okay. 9, 6. What's about to happen? Yeah, I'm getting 2 arrows from the number 9. So what am I thinking this is going to be? Will it be a function or not? No. Why is it not a function? Because here's an x value that was assigned 2 different y values, 7 and 6. Okay? So this is not a function. And it doesn't ask you why, but I'm going to write it down. Because the number 9 is assigned 2 different x values.
Would it be okay if I put, like, not a function, cannot repeat?
Okay, that's what I'm about to write out. You're a little ahead of me. Okay, but let me go ahead and write this answer. And is this relation a function? Yes. Wait. What did I say? Oh, wait, no, I should have said no. Oh, my gosh. Okay, well, I'm not going to get it completely right, and I won't make 100 if I don't say similar question. So just talk me through it. Okay. I'm redoing it. 6 with different numbers. I'm writing up the x values. Why did I click yes on that? 35. 6 I've already done. 49. Now I'll list the y values. 3, negative. Oh, wait. Do you want to leave this question? No. What did I click? Oh. 3, negative 7. I've already listed 3. And then positive 7. And now it asks, is this thing a function? Well, what I wanted to get back, or what you're hinting at, is how do you look at this and tell it's not a function? Well, here's another way you can define function. A function is a list of ordered pairs, that's what we have, in which no x values are repeated. If you went and found a paper algebra book and looked up the definition of function, it's going to either say this, or it'll say this, or it might give you both of them. There's 2 ways of defining function. So, to summarize what I've written there, repeated x's, not a function. So, like right here, there was 9 was repeated as an x value. So not a function. In my, if I'm doing number 2 again, what would I say? Is this a function or not? No. What x value is repeated? The 6. Okay, so is this relation a function? No. Okay. Oh, wait. Before we do this one, I have a question to ask you. So we could write out functions with arrows like this. And if there's 2 arrows coming from the same x value, it's not a function. You could look at ordered pairs. If there's a repeated x, it's not a function. We graphed circles and lines this semester. So what about this? Here's a question. Are circles functions? To answer that, I'm just going to roughly draw a sketch of a circle. I'll draw an x-axis and y-axis. I'm going to draw, really just any type of circle will do, but I'm going to draw one centered at the origin, 0, 0, with a radius of 3. And I don't have a compass up here or some neat tool, so it's not going to look very good. It looks more like a oval than a circle, but pretend it's a circle. And the way I'm going to answer this, is it a function, is by using what I wrote right here. If there are repeated x's, then it's not a function. If we look at ordered pairs on this circle, I'm going to choose this one right here on the y-axis. Again, it's a radius of 3. Could y'all tell me what this ordered pair is right here? Since it's on the y-axis, it would be over 0 up 3. Is there another point on this circle that has an x value of 0? Right here. Like what would this ordered pair be? 0, negative 3. So this is not a function. In general, there's nothing special just about the y-axis. Like right here at the number 1, are there 2 points that have 1 as the x value? Well, yeah, right here and right there. See, this point and this point has 1 as the x value. So once again, x values are repeated. In general, there's something called the vertical line test in algebra. If a vertical line intersects a graph more than once, the graph, what do y'all think I'm going to say, is or is not a function? Is not a function. So if you have a graph and you got to figure out, is it a function? Just draw vertical lines through it. Pretend these are vertical lines. If the vertical line intersects it more than once, it's not a function. How about another question? Y'all love these questions that aren't even homework problems. What about slanted lines? Are slanted lines functions? To answer that, can you just picture any slanted line you want to draw? I'm going to draw. Here's my black slanted line. If I start drawing vertical lines, will it ever intersect that line in more than one spot? Oh, sorry. There. If I draw vertical lines, will those vertical lines ever intersect the graph more than once? No. So, is this a function? Oh, I think it is. It is a function. If the vertical lines intersect only once, it's a function. If it intersects more than once, not a function. That's why the circle is not a function. Starting with problem 3. Okay, is this the graph of a function? This is one of those problems that there's not really anything that you really need to write down. It's a V-shaped figure. And let's see. there's a lot of vertical lines already drawn on here. Well, maybe I should pop this graph out instead. There. Look at these vertical lines, the X, Y, the little grid marks. Do any of them intersect the graph more than once? No, just one time. So is this a function? Yes.
I got confused on the other one.
I can't hear you.
I got confused with something with the other one that you drew.
Oh, well, this one looks a lot nicer than whatever I draw. Okay? The vertical lines are intersecting it only once, so it is a function. Okay? So, yes, let me check it. A student on Thursday pointed out that for yes-no questions, you only get one shot. If you get it wrong, you got to say similar question and do it again. It says final check there. Oh, well, what about this one? If I blow this up, it's not a circle, it's just sort of an oval. Is this a function? No. Look at those vertical lines. You'll see where it's intersecting here and here. Or look at the y-axis. Here's a point. Y'all see where my cursor is? There's a point with a x value of 0. And here's another one. Okay? So, not a function. Okay. Oh, number 5. I think we've sort of already answered the is this a function? What sort of figure is this? Is it a circle? It's a slanted line. What did we say about slanted lines? Are slanted lines functions? Yes. Okay? So this circle, by the way, up here, we could have changed to anything that's just an oval shape, even if it's sort of a flattened circle. It's still not a function. Where slanted lines are always functions. Okay? Yes, this is a function. And this one has more pieces to it. By that I mean it's not finished. It asks you, what's the domain of this graph relation? So they're using that word relation, rather than rule. Okay. Domain, that refers to the x values. Range refers to the y values. It's pretty easy to find those when they're written out as ordered pairs. But what about when it's a graph? Like number 5, a slanted line. When it asks, what's the domain of a slanted line? The domain are the x values. If we call these arrows negative infinity and positive infinity, if I keep drawing this slanted line out, does it keep moving to the left and right? Will it be over here at negative infinity and positive infinity eventually? Yeah, if you keep going, these arrows mean it's moving. This arrow here means it's moving up, but also to the right. So in general, for any slanted line, the domain is all real numbers, and the way we write that is negative infinity to positive infinity. That means it stretches this whole x-axis. Now, what about the y value? Does it go from negative infinity to positive infinity? Is it going to keep going up, up, up? Well, yes. Will it eventually hit the walls? That's what the domain is asking. Will it eventually hit those walls? Will it eventually hit the ceiling and the floor is what the range is asking. The way it keeps going up here and down here, what am I saying the range is for these? Is it negative infinity to positive infinity? Yeah. Okay, a slanted line, it moves left and right forever, and it also moves up and down forever. So we need to type in those negative infinity to positive infinity. What is the domain of this slanted line? That should have been that's a general, you could make a much stronger statement than the domain of this graphed relation. It could have said, what is the domain of a slanted line? For any slanted line, the domain is negative infinity to infinity, and so is the range. Ooh. There. And remember, there's no negative infinity symbol. It's just an infinity. To make a negative infinity, you have to type the negative from the keyboard. And also, with interval notation, you always write the smaller first. That's when it says type your answer in interval notation. That's why you've got to write the negative infinity before you write the positive. You can't write infinity, comma, negative infinity. It'll count it wrong, and it might not give you a hint as to why it's wrong. Let's see. Decide whether the relation defined by the graph to the right defines a function, and then give the domain and range. Let me see. That graph, I'm going to blow it up to answer the... Oh, gosh. That's just... Okay, I don't think I can get such a good graph. So, I'm not going to try to draw it. Okay, I think the is it a function part should be pretty fast. Does this thing pass the vertical line test? Would a vertical line pass through it 2 or more times? I think right there, I'm just looking at the y-axis. There's that y-axis. It's passing through it twice. So this is not a function. Okay. So it's a... we graphed parabolas a while back in that first graphing section. We called them 3-point quadratics. Yeah, 3-point quadratics. You can have, and the parabola would either open up or down. Here the parabola is opening left or right. Generally, we don't use parabolas that, do much with parabolas opening left or right because they're not functions. The rest of the semester, we're looking at functions. I may as well tell y'all. This thing is not a function, and so we're not going to have to graph these type of things, but it is good for us to determine to see that it's not a function, and that it's to determine the domain of range. So first of all, but I want to make a note. That little point for my mouse is, what are the coordinates of that point? Give me an ordered pair. 0, 1. And what about this one right here? 0, 5. You have repeated x values. You have an x being assigned to 2 different y's. That's why that vertical line test says this thing is not a function. But anyway, let's see. Is it a function? No. Now, it's about to ask for the domain and range, and I like this because here it's not just negative infinity to infinity. Look at the graph. Starting at negative 10, go all the way across the x-axis. The graph isn't going from negative 10 to positive 10, is it? These arrows mean that it keeps going up and to the right or down and to the right, but where do the x values start? Here's negative 7 on the x-axis. Is there a point with negative 7 as an x value? No. What's the smallest x value on this blue graph? Negative 4 is the smallest. Now, and realize negative 4 is being used. Where my mouse is pointing, that point right there has an x value of negative 4. So negative 4 is the smallest x value. So it starts going this way. Does it stop? If we keep drawing it out, will it hit the wall over there?
It's going to keep on going and hitting the wall, passing through the wall. So we would say from negative 4 to positive infinity.
Now, let's go ahead and do the range right now. Those arrows, if we kept drawing it out, would it eventually hit the floor and hit the ceiling?
This thing is going up.
Maybe we should undo this.
Okay.
And just look at this. Here you can tell it's more going up and down.
Wait, maybe
when we blow it up. Yeah,
that's better.
Blow it up a little more.
Okay.
Like that. It's going up slowly, but it is going up. Okay? And
so
here,
eventually it would hit the ceiling. What about here? Would it hit the floor? Yes, because it's still angled down. It will eventually hit the floor. So it's going to do from the bottom all the way up to the top. That's the whole y-axis. How do we denote that?
I'll get you started. Negative infinity, comma, infinity. Yeah. It's going up and down forever. That's what that negative infinity, comma, infinity means. It's going to keep going down and keep going up.
But notice it's not going left and right forever. There's nothing over here to the left of negative 4, is there?
It's going to the right forever, but not to the left. It starts at negative 4. Let me type that in. It starts at negative 4. And then keeps going forever. And what about the range? Is it going down forever and up forever? Yes. Ooh, parentheses, negative infinity, comma, infinity, close parentheses. Looking at the graph and figuring out the domain and range can be a little tricky because sometimes, is it really going up forever? Or down forever? Assume that's what the arrows mean. I remember one semester when a student told me it looks to him like it's about to turn around. No, don't assume that. Okay?
The only way you can assume it's turning around is if you see it's going down. Any questions there? There's graphical analysis. There's not that much to write. It's just what we're saying in our explanation. Any questions? Okay, let's see number 7.
Something called function notation.
I'll do function notation. I tried to write out a few sentences for an announcement on Canvas, and it's become half a page at this point. And so,
does everyone know what he's talking about? Wednesday is the quiz test day. If you want to bring a computer and take the test here rather than taking it at home, if you have a Chromebook, it has to be here because we're going to have to do something to
get around
that lockdown browser and monitor system. Okay? And it was my brother that figured it out. How to do it. Okay?
Oh, I felt so smart that day. Okay. There. Function notation. Okay, I'm going to look and see. Okay. I think I'm going to write a definition now. We've defined functions as a rule that assigns each x value to one and only one y value. And we're making a note. We defined it also, the tabulation method, where a function is just a set of ordered pairs. That rule is assigning x values to y values. I'm going to say a function is an algebraic equation. I'll write the sentence and then we'll take it apart and see what it's trying to say. An algebraic equation that assigns each number in one set called the domain to exactly one number in another set, and this other set is called the range. A function is an algebraic equation. Well, I know what an equation is. Anything with an equal sign is an equation. 1 plus 2 equals 3 is an equation. It's not an algebraic equation. What do you need in order for it to be an algebraic equation? When did you switch from a study of arithmetic to the study of algebra? The letters, that's it, okay? And so for the domain value, keeping in mind, we said the domain was the set of all x values. So the most commonly used letter in a function for domain values is x, but we could use any letter for a domain value. I know that in Math for Business, we frequently use Q's for quantity, or T for time. So Q or T, etc. But the most common domain variable is x. For range, what do you think the most commonly used variable is? Oh, I think I wrote it, didn't I? Range is the set of all y values, so a y, but once again, you could use any variable. In my business calculus class, we use C for cost functions, and we use P for profit functions. It can be any letter, but the most commonly used letter is y. With function notation, we can replace the variable y with the notation f left parentheses x right parentheses. That's read as f of x, or function of x. And that of in parentheses does not mean multiplication. This function notation gives us a very nice means of evaluating functions. If we look at what number is it, 7? Okay. Find the indicated outputs for f of x equals 5x squared minus 2x. The outputs. It reminds me of that when they decided, math books decided they needed to make functions more concrete so people would understand them better. And a lot of math textbooks introduced function machines. Did Tony mention the function machine nonsense to y'all? Oh, I should have said that. I'm being recorded on her. But there's function machines where you have a little picture, the x value drops into the little machine, and it comes out as a y value. Well, I really think that these functions are abstractions. We are engaged in abstract thought here. There are no function machines out there in the world where you're dropping x values in and it's spitting out y values. But anyway, that was one of the terminology, output. It reminded me of the failed pedagogical attempt a couple of decades ago to try to make these functions concrete for people to really understand what they're doing. There are no function machines out there, so these are abstractions. This is abstract thought. Okay, they want us to find, look at what they're asking for. They want us to find f left parentheses 0 right parentheses. That's f of 0. To to find f of 0, what that's saying to do is the number in the parentheses, that's going to be the new x value. That's telling you, go to your function f, and wherever you see an x, replace it with 0. So I'll say replace, oh, I didn't switch. Thank you. I'm writing away and y'all are just not able to see it. There. Okay. So we want to find f of 0. Here's our new function. So that's saying replace x with 0. And hold on. Let's see. There, I did that. So we're going to come up here. Wherever we see an x, we're going to plug in a 0. So f of 0 is equal to, replace that x with 0. 5 times 0 squared minus 2 times 0. Remember your order of operations. You perform exponentiation before multiplication. 0 squared is 0. Then you start multiplying from left to right. 5 times 0 is going to give me minus 2 times 0, 0. So f of 0 is 0. When x is 0, the y value is 0. That's not a very interesting problem. Hopefully they'll give us some other numbers to plug in. Let's see. So when we plug in 0 for x, the y value is 0. F of negative 1. Let me write it down first. We're still using that same function. We're still on number 7. So let me do this. F of negative 1. That says go to your function f, and wherever you see a variable, you're going to replace it with negative 1. So we have 5, replace the x with a negative 1, replace that x with a negative 1. And once again, don't forget your order of operations. What are we going to do first? Okay, negative 1 times negative 1 is positive 1 times 5. That gives me a 5. What about this? We have a minus 2 times a negative 1. We simplified the first term here. Negative 2 times negative 1, that's a positive 2, to give us a final answer of 7. That means when x is negative 1, the y value is 7. Remember that earlier we said that a function is a set of ordered pairs. This equation is generating ordered pairs. What ordered pair did we just generate here? When x is negative 1, what was the y value? 7. So we just generated an ordered pair. Just like up here, we generated the ordered pair 0, 0. That function is an ordered pair generating machine. So when we plugged in negative 1, we got 7. What about f of 2? I'm going to have to go to another page now. Okay, let me... This is still number 7. I'm just writing down. Okay, hold on. There. And they want us to find, what was it? I forgot. F of 2. They want us to find F of 2. That's telling us to go to our function, and wherever we see an x, replace it with 2. Okay. So we're replacing each x with 2. Two squared is 4 times 5 is 20. What are we going to have here? So it's going to be a negative times positive. It's going to stay a negative 4. What's that going to give us for our y value? 16. I agree. So when x is 2, the y value is 16. Any questions there? When using function notation, whatever is inside the parentheses, that's what you go through and replace the variable with. Given the function h, describe h of x equals x plus 9. Oh, by the way, the most commonly used letter for function notation is f, because the word function starts with the letter f. But you can use any function name you want to. As I mentioned earlier in that business calculus class, we have cost functions, c of x, and profit functions, p of x. And so you can use any letter you want to for the name of the function. It looks like in number 8, they're giving it the name h. Okay, let me write down the function. This is number 8. Oh, I don't like that pen. Let's see. So h of x is equal to x plus 9. And they want us to find, first of all, h of 0. So the first thing we're doing is finding h of 0. H of 0. That says go to x, go to h, and wherever you see an x, replace it with 0, so we have a 0 plus 9, which is just 9. Once again, realize we're still generating ordered pairs. When x is 0, the y value is 9. Okay. When x is 0, the y value is 9. What about h of negative 6? Let me write this down. Okay. This says go to your function h, and wherever you see a variable, an x, replace it with. Replace it with negative 6. Okay. Negative 6 plus 9 gives me a y value of 3. So h of negative 6 is 3. H of negative 18. H of negative 18. That says go to our function h, and wherever we see a variable, replace it with negative 18. Oh, the light's going on and off. Yeah, you were so still, the motion sensor decided no one was over there, okay? I'll dim those lights in a minute for you. Let's come over here. Oh, goodness. Okay. Oh, what did we get there? 9? Oh, -9. Thank you. Oh, how many parts does this thing have? Now we want h of 9. Let me write it down. H of 9. Okay, sweet. Oh, okay, so they say it there. Good. Okay. This says go to our function h, and wherever we see a variable, replace it with. So we have a 9 plus 9, which gives me a y value of 18. Oh, this is a good one. Now we want h of y plus 12. Okay. We're going to go to our function h, and wherever we see an x, we're going to replace it with what? No. What's inside the parentheses? Y plus 12, that's what we're going to replace the variable with. We go up here, we replace the x with what's in the parentheses, y plus 12, and I still have what stuck on there? I have something else stuck on here, the plus 9. And, well, there's no other y to combine, so that just stays a y. 12 plus 9, is that a plus 21? For my final answer. Whatever's in the parentheses, that's what you go replace the variable with. We replace the x with 0. We replaced it with -6. Down here, the thing in the parentheses was y plus 12. We replaced that variable with y plus 12. Any questions there? Okay, I'm going to do another one, okay? One more before we go on to that one. H of...
Oh, wait. Wait, so you're doing another... Okay,
Yeah, I'm just pretending there's another part here. H of W minus 4. That says go to your function h, and wherever you see an x, replace it with W minus 4. Okay, so in place of that x, we have a W minus 4, but we still have what? The plus 9, to give us a final answer of W negative 4 plus 9.
Plus 5.
Okay, well, I was waiting for them to answer. They answer better when you're not here, Tony. Okay? Any questions? I just want to make sure you realize whatever's in the parentheses, that's what you replace the variable with, even if it's got another letter. Okay, number 9. Given the function g described by g of x equals 6x, this is number 9. So g of x is just 6 times x, and they want us to find g of -3, g of 13, and g of 31. Okay. Pushing it up. Okay, g of x is the function defined by 6 times x. We want g of negative 3. That means go to g, and wherever you see an x, replace it with. So that's instead of 6 times x, we have 6 times negative 3. 6 times negative 3 is negative 18, I agree. Oh, this is good. We can just get all the values and then type them in all at once, okay? G of 13. That says go to G, wherever you see a variable, replace it with. You come up here, you replace the x with 13, I agree. And 6 times 13, is that 78? And one more, G of 31. This says go to G, and wherever you see an x, replace it with 31. And 6 times 31, is that a 186? Okay. $78 and 186. Any questions there?
That would have confused me when I typed it in. You put in each one, and then you say next, and then what's the next one? I'd be screaming.
Oh, wow. Okay. Next one.
I'd be thinking it didn't let me finish, or it was just going to take that one answer.
Yeah.
Uh-huh.
I thought we were going to type in all the answers because the way they listed it, A, B, C, I thought we were going to type them all in there. But
Yeah, I was expecting the same thing. So, okay, is this one going to be hard or not quite so hard?
and f of x is equal to negative 2x plus 5, and they want us to find f of, what's in those parentheses? N like Nancy. Okay. This says go to our function f. There, okay. Go to our function f, and wherever we see an x, replace it with n. It's just a change of variable. Instead of negative 2x, what are we going to have? Negative 2n plus 5. It's just a change of variable.
That one really isn't that hard.
That's right.
Negative 2n plus 5. $11. Now that's
Okay.
good. No,
Not too hard.
Yeah, not too
but-
hard. If there's something really hard, I'll never say it. Okay? Until it's just plainly obvious. Oh, wow, this is a lot of work.
F of x is equal to negative 5x plus 6, and they want us to find f of 2n minus 5. Okay, let's say it in words. What does that function notation say it? It says go to f, and wherever you see an x, replace it with 2n minus 5. So negative 5 is going to have to be multiplied by 2n minus 5. And what else do we have stuck on there? the plus 6. Well, in order to multiply negative 5 by 2n minus 5, what are we going to have to do? It starts with a D. Distribute there. Oh, what did he say? Delay? Divide. Oh, yeah. Distribute. The other D. The other D. Move your hands in the air. What's that going to give us here? Negative 5 times 2n is negative 10n. I agree. Negative 5 times negative 5 gives me a positive 25. And we still have a plus 6. What can we do to simplify this? There's only one step left. Add the 25 and 6 to give us negative 10n plus 31. Negative 31. Any questions there? Tommy, you want to take over? Okay, Tim. Okay. So, we've looked at functions being rules. We've looked at them as ordered pairs. We've looked at them as equations. Let's look back at this function notation with ordered pairs. Oh, I forgot to put it on. Oh, okay. I'll talk louder. Okay? Number 12. Here the function is written as an ordered pair, and we're told find f of negative 2. So you're not really going to be plugging in here. Okay? So write down that function.
Does that square it off in the first? They both look square.
Let me see if I can make it a little...
Well, just switch over to my writing.
Oh, okay.
Yeah, that's
Okay.
So
That's
those just the set braces that they put around...
they're just the set braces that you put around sets of numbers, and then the other things are ordered pairs. And they want us to find...
Is it right down what it said?
No.
Oh, okay.
Oh, f of negative 2. No. Okay, switch back. Now, earlier, when we were going through this stuff, I'd say, when x is 0, the y value was 9. When x is negative 6, the y value, I was saying that, calling this stuff the y value. The value of the function is the y value. And if you understand that, then you should be able to answer this. When x is negative 2, the y value is 7.
Here there's no writing to do the problem. Number in the parentheses is x. Your answer is, another
Y.
x. It looks like it's supposed to be y.
Y. So, is there another part to this? Surely
No,
there's
but let's make up another one. Let's
Okay.
find f of negative 1.
f of negative 1. When x is negative 1, what's the y value? Negative 2. Okay, I agree.
So these questions will only have the one answer.
Yeah,
The y value, the one
yes,
answer.
and-
Okay, here's a good one.
this has only got one part.
Oh, what
Let
is
me- let me-
Okay, we'll go type in the answer. But I think this makes a good. I have a good question now. I have a good one.
Okay.
Suppose I'll do one more. Suppose they'd ask for f of 3. When x is 3, the y value is 8. I agree.
That's the only 3 possible problems that could have an answer with number 12.
Suppose I asked you for f of 5. When x is 5, what's y? Is 5 in the domain of the function? No, 5 isn't in the domain. It's not an x value. So f of 5 would be undefined.
In fact, you can make a more general statement. F of anything other than -2, -1, or 3, undefined. Right? There's no x value of 20, so f of 20 is undefined. But
the value of the function is the y-coordinate at the given x value. Any questions there?
So can I put not in the domain?
For f of 5, you'd say undefined because 5 is not in the domain.
in some of the math courses on Pearson, they're starting to add the writing and thought things like that. I know in trigonometry it's already there. So you're writing the steps and stuff.
Oh, yeah.
Okay, but eventually this is going to be much more, it's already more general than what.
And I like that.
Yeah, but eventually there'll be a
I don't know
lot
that
of
the students will like it, but I like it. Okay,
Yeah.
keep going.
Okay. Oh, wait. Just for the record, just for the heck of it, if someone wanted, I've taken number 12 and said similar question. What number would I type in here? A 9. Can y'all see that? X is -6. So that would be, notice there's 2 ordered pairs with -6. But the one in which -6 is an X is this first one. Y is 9. Now, let's look at graphs and do the same thing.
Well, before you blow up that, okay, let me write down.
This is going to be one where you just sort of look at the graph. There's not really any writing, but he's going to write down the problem and put down the answers. So he's just writing it down.
-2, 0.
Oh, Tim, but I'm just showing them what you're doing. They're sitting there wondering.
1 and 4.
1 and 4. This goes back to the X and Y. The number in the parentheses is X.
The number in the
answer is Y. So I'm going to
blow up that graph.
And then we'll punch in all 4 answers at the same time.
That's what I'm writing them down.
Okay.
First of all, f of -2. When x is -2, what's the y value? Look at the graph. When x is -2, do y'all see that point there?
Is this the point we're looking at?
What's the y value? 0. I agree. I'll write that down. Next we want f of 0. When x is 0, what's the y value? 4. I agree. We want f of 1.
Ooh, where's 1? Let's see. That's 2, so this is 1. Scan up. What's the y value right there? 2.
I agree. And finally, one more, f of 4. When x is 4, what's the y value? 4. So we have 0, 4, 2, 4. Any questions there before we punch in the answers? There are 3 different ways of expressing functions. You can express them graphically, so we know how to use function notation there. You can express them with those just lists of ordered pairs. And we've done, that was number 12. And then those other ones, the most common way of expressing functions is as an algebraic equation, and that's the ones we were looking at earlier.
Remember,
So,
years ago, a
0,
student asked me,
4, 2, 4.
how would you do this without looking at the graph? They didn't want to look at the graph to do it. It was like, well, you can't. You've got to look at the graph. Yeah, but what if you didn't have the graph? Then it wouldn't be this problem.
2.
And I think the student left the class thinking, that idiot doesn't know how to do the problem if there's not a graph. Well, for this particular problem, there has to be a graph.
Because the instructions say use the graph of y equals f of x to find.
Otherwise, it's better give you a set of ordered pairs, or what's the other way? Give you
Equation.
an equation. Okay, something like this.
Oh, go back to that graph. I have a good one. I'm going to make up a part. I'm going to make up a part E. Go back to that graph. I want f of 6.
Oh, you and Jim, suppose it just said find f of 6.
Look at that graph.
Here's 6 on the x-axis. Is there a y value there?
6 is not in the domain. And so f of 6 would be undefined.
No graph at the 6.
And when you're looking at a graph, you can determine the domain. It's just whatever numbers on the x-axis that are used, okay?
Like right here, the domain would be -2 to, positive 4? The domain would be, the x values are -2 to positive 4. Now, that would have been a good question, but they
What's
don't
the
ask
domain?
that. And what about the range on here? The y values are all between what two numbers? 0 and 4.
I agree.
But the natural question to ask is, how do we find the domain if it's given as a equation? It's easy to find the domain when it's just ordered pairs written out.
Okay,
What if
switch
we have
over.
this-
I'm going to write something.
Oh, you're not going to... Oh,
No, not yet.
okay.
Okay, domains of algebraic equations. That means the function is given as an algebraic equation. There's something called the assumed domain. Unless you're told otherwise, assume the domain is the set of all real numbers that can be plugged into the equation to yield another real number. I'll say, unless told otherwise. Tony, I haven't read that yet. Assume the domain, okay, good, is the set of all real numbers that can be substituted for x. I have a desire to say that can be plugged in for x, but I guess I'll say it more formally. That can be substituted for x to produce a real number and in parentheses, I'm going to stop right here and there are two different instances where we were working with numbers this semester and we didn't get real numbers. One of them was an undefined result. You don't want an undefined result, so I'll say not undefined. And another time that we were working with numbers, but they weren't real numbers, was with imaginary numbers. So we We don't want an undefined result. We don't want an imaginary number. So it's the set of all, you assume the domain is the set of all real numbers that can be substituted for x to produce a real number for y. You don't want an undefined result. You don't want an imaginary number. That means we have to avoid two things. Avoid. There are two things to avoid. Undefined results. When does that occur? I'll get us started. It involved a fraction. There was a fraction. When is a fraction undefined? Remember my little trick? A number divided by 0. What does that say? NO? No, you can't do that. You can't have a denominator of 0. You want to avoid a denominator of 0. Well, when do we create imaginary numbers? To get imaginary numbers, there had to be a square root. But what had to be underneath that square root? A negative, okay? You're trying to avoid two things. Denominators of 0, square roots of negatives. So you're trying to avoid denominator equal to 0. You're trying to avoid square roots of negative numbers. Square root of negative numbers. Hold on, let me see if I can do this. Oh, it ain't gonna work. So with that in mind, looking at, oh, look at that. They give it to us as a nice little multiple choice. Well, I'm going to cover up those options. Find the domain of the function f of x equals 3 over x plus 2. This is number 14. Let me write down the problem. This thing back down and switch. All that writing I wrote looks impressive, but in reality, this is all you need to know when it comes to finding domains. You don't want a denominator of 0. You don't want a square root of a negative. We want to find the domain of f of x equals 3 over x plus 2. Will this function produce imaginary numbers? In order to produce imaginary numbers, what would you have to see appearing in the equation? Well, that's the imaginary number, but what creates imaginary numbers? Will this thing create imaginary numbers? In order to create imaginary numbers, your equation must contain what symbol? A square root. There's no square root, so I know there's not going to be any imaginary numbers. Will this equation produce undefined results? This reminds me of those cut points. Think about the denominator cut points. We don't want the denominator to be 0. I guess I should say denominator not equal to 0. Isn't that what we would do? We'd say, oh, here's the denominator, x plus 2. How would we find denominator cut points? We'd say we don't want that set equal to 0, which means that x cannot equal what number? Negative 2. That's saying that you can plug in any real number you want to except for negative 2. If we were going to write it out in words, the domain is all real numbers except negative 2. All real numbers except negative 2. Could you plug in 50 million for x? Yeah, that'd be fine. Could you plug in 17 billion for x? Could you plug? Yeah. What's the only number you can't plug in for x? -2. They want us to express this concept using interval notation. So let's just think about a number line. Here's a number line. Do y'all remember when drawing the number line and labeling denominator cut points, we never shade in denominator cut points. We always used an open circle. That said, we're not using -2. But it can be anything to the left of -2. It could be anything over here to the right of -2. Does it stop? Do those intervals stop? No, they keep on going. There's negative infinity and positive infinity. They want us to express the domain using interval notation. We're going to have to use two different intervals. Okay, it goes from negative infinity to -2. Am I going to have any brackets in my interval notation? No, because I don't have any closed circles. Remember, with infinities and negative infinities and open circles, those are just parentheses. So we'd say parentheses, negative infinity comma -2, and then union. Y'all remember that little union symbol? -2 to positive infinity. And here is what they want for the answer. Personally, I like it when you type in the words, the verbal description, all real numbers except -2. But they're looking for interval notation. This interval says every number to the left of -2. This interval here says every number to the right of -2. The only thing that's not being included is -2 itself. Any questions there? You don't want denominators of 0. So if you have a fraction, make sure that denominator is not 0. Move over here. Oh, this is nice. We don't have to type it in. A, B, C, or D. D. There it is, the numbers to the left of -2. Here it is, the numbers to the right of -2. Oh, let's see. Another one. Oh, I like this one. I don't even have to write anything down. I know the domain. There are two things we want to avoid. We want to avoid denominators of 0. We want to avoid square roots and negatives. Well, will this thing ever have a denominator of 0? I'll tell you right now it won't, because there's not a what appearing? A fraction. There's no fraction, just like with the cut point method of when we were solving inequalities. If there were no fractions in the inequality, you didn't have any denominator cut points. So likewise here, no fractions, so you don't have to worry about a denominator of 0. What about imaginary numbers? Are you going to get any imaginary numbers here? No. So, unless you're told otherwise, what do you assume the domain is? All real numbers, negative infinity to positive infinity. My first semester at Del Mar, I was teaching, that was before I was in the UN, so I didn't have a permanent room. They'd move me around. Oh, for these two classes, you're over here and stuff. But I remember I was teaching beside Dr. Shing's classroom, and my class got out earlier, and I went walking past his room, and I heard him saying, no fractions, no square roots, the domain is all real numbers. And I thought to myself, that's a very good way of saying it, okay? If your function has no fractions and no square roots, you assume the domain is all real numbers. And it should be obvious why. If there are no fractions, you can't get a denominator of 0. If there's no square root, you can't get a square root of negatives. So, okay. So, suppose this were the question. What would you choose? A, B, C, or D? Find the domain. Any questions? Let's see. Okay, find the domain of. Hold on. Let me write the problem down. I'm going to hide the answers. This is number 16. Let me write the problem down. Find the domain of the function f of x equals 2 over x minus 14. Oh, there's two fractions in this equation, plus 4 over x minus 4. Let me switch over. Trying to stop y'all from seeing me. Just out of curiosity, do you expect this function to create imaginary numbers? No, because there's no square root. Good, okay. Do you expect undefined results? Yes, because I see fractions. Let me make sure I copied that down. I thought that was an x plus 4, not an x minus 4. Did I write it down? No, that's right, okay. I thought I miscopied the problem. You don't want either denominator to equal 0. So to find the domain, x minus 14 can't be 0, and x minus 4 can't be 0. That means x cannot equal positive 14. Oh, are you doing this one here? X can't equal 4, positive 4, and positive 14. Could x equal 50 million? Yes. The only things that you can't use for x values are 14 and 4. So if we were going to write it out in words, the domain is all real numbers except 14 or 4. You could plug in pi if you wanted to. You could plug in negative 50 million if you wanted to. You can't use 14 or 4. And they're going to want that at interval notation. So let's think about our number line. Here's our number line. There are two numbers we're excluding. Put them in numerical order. Remember, with interval notation, you have to go small to big. So what goes here? 4, and there's 14. X can be anything else. So X can be right here to the left of 4. It could be between 4 and 14. Or it could be bigger than 14. And we have to express each one of those intervals. Now, remember, these are open circles. Am I going to have any brackets in the interval notation? No, it's all going to be parentheses. So I'll do the first one, okay? That's negative 8 to 4. So negative 8, comma 4, union, open circle, so it's parentheses. What am I going to have here? 4, 2, 14, union. Here, 14, I agree, 2. Well, this is multiple choice. You know, I bet you we could have just looked at once I drew the graph, you could have picked out the interval notation, because this is multiple choice. They're not all going to be multiple choice. They won't all be multiple choice. A, B, C, or D. Okay? Well, there's only one that has 3 distinct intervals. This is to the left of 4, between 4 and 14, and to the right of 14. Any questions there? Okay, I want to look at 17 and 18, and I'm going to have them done. I want to do them on the same piece of paper. Okay. Start off. Tony, I'm ready for 17 and 18. You said you want to do these?
Oh, okay.
Because you said to do them on the same sheet of paper. There you go. Okay.
Well, when we find the domain of a square root function, we have to make sure that there's no negative numbers under the square root. We're no longer interested in imaginary numbers. When we start talking about x and y, there's only real numbers on the x-axis and y-axis. So, I'm going to give you a strategy on how to solve or how to find the domain of a square root function. You take what's under the square root symbol and say it must be greater than or equal to 0. It's okay to have a 0 under a square root symbol. Pull up that calculator and show them. Put a square root of 0.
Square root of 0 is perfectly fine. The square root of, what's the square root of 0? 0. That's a real number. That thing under there, it can't be negative. You can't decide, oh, I'm going to plug in 100 for x. 20 minus 200, that'd be a negative number under there, okay? But the smallest that thing can be under there is 0.
So if it says find the domain, and you have a square root function,
oh, is that pen
start
going
off,
dead? That's my favorite pen.
You start off by taking what's under the square root symbol and saying it has to be greater than or equal to 0. We're going to solve that inequality using cut points. We will never look at the function again. At this point, we're going to pretend this is just a real easy cut point method problem to solve something that has a less than or a greater than. The first thing you do is solve it with an equal sign.
Make a note. Use the cut point method.
Okay.
Remember, with the cut point method, you ask yourself, when is it equal? Then when is it undefined? Everywhere else, it's either greater than or less than. So here we're finding the SCPs. Do you remember what does that word S stand for?
That letter S.
S, I mean. What does that letter S stand for? I know C is for cut and P is for point. Here we're trying to find the solution to this equation.
So it's a solution cut point. But let's see, how would I solve this for x? I think I'm going to move this 2x over and then divide by 2. So our solution cut point is 10. With solution cut points, you look at the symbol to decide is it equal to, is it open circle or closed circle? Does anyone remember if there's an equal sign on it? Is it going to be an open or closed circle? Closed. It's the one that uses more ink. Okay? So, again, y'all didn't have any cut point problems where there's only one cut point. So this one's easier than any of the other cut point problems y'all have done. Draw your number line. Label your cut point with a closed circle. And do y'all remember what I like? What number do I like to use as a test point? 0. Where would 0 be? Between negative infinity and 10 or between two positives? Always between a negative and a 10. So, excuse me, between a negative and a positive. So I'm testing 0. Again, when I'm testing it, I'm just plugging it in here to the statement. The 20 minus 2x is greater than or equal to 0. If I put a 0 in for x, I'd have 20 minus 2 times 0 would just be 0. Is this a true statement? 20 is greater than or equal to 0. It's sure not equal to it, but I think it's greater. So am I going to shade that first interval or cross it out? It's the thing about algebra. When you study something, it's eventually going to pop back up. That cut point, you might have thought, oh, I'm through with those cut points. No, no, no. In algebra, you're never really through with anything. So it'll pop up. That was a true statement. So what am I going to do with this interval over here? Do y'all remember? Cross it out. So what's the interval notation for this shaded interval? Parentheses or bracket? What are you going to type first? Because you're going to have to type this answer in. Parentheses. You always use a parenthesis with a negative infinity or a positive infinity. Comma. What's going to go after the 10? Bracket. Yeah. Okay. So you're going to type it in, Tim? So here's a systematic way to find the domain when it just says f of x equals square root. So for a square root function without a fraction, you set the thing under the radical greater than or equal to 0 and use the cut point method. You'll notice, did I write a square root symbol anywhere? Oh, well, write the answer and then did I write a square root anywhere else? It was here in the original problem. Did I need to take a square root anywhere else? Say no. Okay. If you find yourself with a lot of square roots, you're doing something wrong. So negative infinity to 10. Type it in. Okay. Negative infinity, comma, 10. Bracket. And hold on, checking. Okay. Look at this problem. Compare 17 and now number 18. I'm wondering if y'all can tell a difference. There's a huge fundamental difference regarding the square root. It's a fraction. In particular, that square root is in the denominator. Now, on the previous problem, oh, this is one of those multiple choice ones. Yeah. There were quite a few. Oh, okay. In the previous problem, the square root was not in the denominator, so it could equal 0. But on this one here, can that denominator be 0? Can that square root be 0? If we have a 1 over 0, will that be a number or one of those undefined? Can the denominator be 0? Say no. Okay. No. So instead of setting the radicand greater than or equal to 0, you're going to have to set it just greater than 0. So how do these differ? If there's no fraction, you take what's under the square root and go greater than or equal to 0 and use the cut point method. If there is a fraction, you take what's under the square root and go only greater than 0. That's the only difference between these two types of problems. because you wouldn't ever want a 0 down here. If you put a negative 7 in for x, you'd have 1 over 0, and that would be undefined. Now, this is a cut point problem easier than anything you've done. We just solve it as x plus 7.
You see, notice if you get a denominator of 0, you'd get an error. Division by 0 is undefined.
Oh, let me move that. I'm just trying to show that we're no longer going to do anything but that 1 over square root. All I used that for was to get the thing under the square root and put it greater than 0. That's the cut point problem I'm solving.
Right, again, write out. Use the cut point method.
Oh, okay. Use cut points. So, negative 7 is my solution cut point. Is it going to have an open circle or a closed circle? Open, because there's not an equal sign on there. Okay, just an open circle. Draw your number line. My number line. Oh, I'm sorry about that.
So, here's negative 7. And y'all said that would be an open circle. There's negative infinity and positive infinity. What do y'all think I'm going to test? 0? Where would 0 be? Between negative infinity and negative 7? Or negative 7 up to positive infinity? Okay, so right here I'm going to test 0. I'm testing 0. I'm plugging it into that green inequality. I'd have 0 plus 7 is greater than 0. 0 plus 7 is just 7. 7's greater than 0. True or false?
Shade it or cross it out? Shade it, yeah. It's true.
So what do I do on the other side of negative 7? Here. Cross out. So how do we express this interval? Call it out as if you're typing it in.
Parentheses or bracket?
Parentheses. Left-hand endpoint.
Negative 7.
Negative 7. Comma. Right hand. Infinity. And what goes after the infinity? Okay.
At any time did I use that fraction 1 over square root of x plus 7?
I guess
No.
you used it right here at the beginning when you said, oh, it's a fraction. I can't let the denominator equal 0. So you decide just to use a greater than. That's
Yes,
really the only
on
time.
Thursday, a student said to me that she thought of it as a denominator cut point and still got an open circle,
Yeah.
and it still all worked out exactly the same. And I said, yeah, that's a good way of doing it. I don't know. I just thought on both of them, just say solution cut points. Have the equal sign when there's no fraction. Just greater than 0. No greater than or equal when there's a fraction. Okay? Let me type that in so you'll feel confident that... Oh, wait, I have to type it in. Oh, wow. Which one is it?
No, it's not A. Look closely at A. I
think
think they have a bracket in front of the negative 7. Can you blow it up?
Oh, where's the little dot that let you blow it up?
Oh, I think just try
Oh,
this.
okay, yeah, that.
Well, it ain't one to do it. Oh, well. There, you blew
I
it
did
up.
blow it up. Okay. Oh, but you see, that's why I'm not blowing it up, because, okay, but there is a parenthesis on D and bracket on A. So we'll check our answer and let me get it back to a normal size.
Any questions there?
One more, and y'all tell me, are we gonna, well, there's no square root symbol in it, so don't start doing cut points, okay?
I know what to do here, Tony. Don't
okay.
worry. I know. Let me
Similar
write the problem.
is it 16?
Okay. Find the domain of the following function.
Oh, it says do not use a graphing calculator. If you want to use a graphing calculator, go for it.
Okay.
Let's see, which one? I'm thinking of one like, got 16 there. That was pretty easy, wasn't it? Everything except, 14 and 4? What do y'all think we need to do on 19? Like, this was easy because there were no exponents, right? What am I doing a poor job at hinting that we're going to have to do to this denominator?
Okay,
So-
let's take another approach. Will this function create any imaginary numbers? No, because there's no square root, okay. Will it produce undefined results? Yes, because I see a fraction. What do we not want to have down here? Okay, we don't want that to be 0. Oh, switch over.
Oh, yeah.
X squared minus x minus 6. We don't want that to be 0. Now go back to that one that Tony was trying to reference. Where was it?
There, 16.
16. Up there. Yeah, there it is. This was easy because the things were all just linear factors. We didn't want them to be 0. Well, this thing isn't linear factors. What are we going to have to do?
What did I do?
X squared minus x minus 6. What are we going to have to do to that left side?
We're looking for one word in particular. It's one of the F words in algebra.
No,
foil,
it's not
but-
4 letters, though.
Huh? The other F word?
Factor. We're going to
yeah.
have to factor this. Y'all know what to do here. It's basically a quadratic equation. X squared. What will I use? X times x. And let's see. For 6, it's 1 times 6 or 2 times 3. What do you think we'll use? This is a simple trinomial, so it's easy to choose the pair to use. The pair you use, in this case, is going to have to subtract to give you, what's that number there? No, the number in front of x. If you don't see a coefficient, you assume it is 1. Oh, and that last sign's a minus, so what do you know about the signs? Okay, a plus and minus. If the last sign's a minus, you're going to have 1 plus and 1 minus. I'm going to write it in right there. Where do we put the 2? Where do we put the 3? So that the outer and inner give us back that negative 1x. I can't hear you. The first one is 2. The last one is 3. 2 plus a negative 3. I agree, that gives us the negative 1x. And now, we have 2 separate factors. We don't want either of them to be 0. So x cannot equal here negative 2. Here, x can't equal 3.
In words, the domain would be all real numbers except negative 2 and positive 3.
All real numbers except negative 2 or positive 3.
But you can't type that in. It wants interval notation.
Now you
Let me
can
check that. You see, it said type your answer in interval notation. It doesn't want words.
These are like denominator cut points. You never want a denominator to be 0, so how am I going to label these numbers? Open or closed? Open.
Because open means don't include. That's the except.
And remember, you put them in numerical order. So which number's here? The smaller one and then the positive one. The negative one and then the positive one.
Darken everything.
And then, can X be 50 million? Could you plug in 50 million for X? Yes. The only numbers you can't use are -2 or +3. So you have this whole interval over here. You have this one here. And there. I don't know. There. And there. And there.
Write it out.
So, is this a multiple choice or a type in the answer?
Oh, I thought it was type in.
Let's see.
Yeah, it's type
Yep,
in.
so y'all got to call it out to me. Call it out as if you're typing. Parentheses or bracket. Left-hand endpoint. Negative infinity, comma.
-2.
Parentheses or bracket. Okay, that's it. All the numbers to the left are -2 on the number line. Or this interval here, call it out as if you were typing it in. Not before the -2, I'd have to type in a parenthesis and then the -2, comma, 3, after the 3, union, this interval, parentheses, 3, comma,
Infinity.
here. Okay.
I'm going to start typing that
Start
in.
typing it in.
Parentheses, negative infinity, comma, -2, close parentheses, union,
Parentheses,
-2, comma, 3, union, 3, comma, infinity, close parentheses, check answer. Okay. And that's just a fancy way of saying what?
All real numbers except for
-2 and +3.
correct.
Now, let me see. Hold up there. Oh yeah, leave it there. Okay. I want to mention something right now while it's still recording. For my class, Tim will post his announcement later. After this class. But here's what I've posted. Hopefully it'll get students that aren't here to read it if they're going to come to class on Wednesday. Or do you think they'll just, I better just not go to class on that day. Let's read what it says. As stated on the syllabus, the Pearson Lockdown browser and monitor system doesn't work on a Chromebook, only operates on a Windows or Apple computer with a webcam. If you have a Windows or Apple computer with a webcam, then you can take the tests and quizzes at home. If you only have a Chromebook, you'll not be able to take the tests or quizzes at home using the monitor system. Therefore, we've set aside some days for students to take the Chromebook to class so they can take the quizzes or tests. Students can bring the Chromebooks to class and connect to the college's Wi-Fi. Then they can take the quiz or test without the monitor system because all proctored the exam. Realize you must have met the prerequisite. You have to be ready to take the quiz or test. Then a new paragraph. Classes on Wednesday, October 12th, 2022 will be used for students with Chromebooks to take the quiz or the test. If you have a Chromebook and are ready to take the quiz or test, bring it to class on Wednesday. I'll proctor the exam. That's all we're doing on Wednesday during class. If you've already taken the quiz or if you plan to take them at home, then you do not need to come to class. Only those students with Chromebooks who need to take the test should attend on these days. No lecture on Wednesdays, so no new videos. If you have a Windows or Apple device but you do not want to install the Pearson monitor system, then you should plan to take the quiz or test on this day also. Okay? Is that self-explanatory? And for anyone that's watching this video, say next year, ignore what we're talking about right now. Okay? But I wanted to include it on the video for people that aren't here today but listen to or watch the video. Okay? Any questions? I'm going to hit stop.